Alrighty, so test number 2, kinematics. The very first thing you have in your binder should be this sheet that is entitled Kinematics in One Dimension. It has a picture of some guys riding a bike. Have you got it? Okay. What was in there that's of extreme importance? You've got the formula V bar equals D. You've got some, actually, you do have some definitions. Definitions of mechanics, kinematics, and dynamics. Okay, so there's a couple of definitions there that you should probably be aware of. Yeah, just like DEFN is good, probably. Anderson. Okay. Really, this first little bit was really just sort of a review of grade 10 sort of stuff. We talked about reference frames. You should have some idea of what a reference frame is. And of course, you need to be able to convert from kilometers per hour to meters per second. That is a given. I think there was a few questions at the end that sort of pulled out the important parts out of that little package there. I asked you to define mechanics, kinematics, dynamics, translational motion. I asked you to write the formula for average speed, and I asked you to do some conversions. So, is that enough? Do you want to add anything? You guys don't have to write. You can we'll print this out or we'll put it on Schoology. That's why we're doing it. Okay? I believe at some point then there were some notes that I wrote or that I did up on a slideshow talking about linear kinematics. Again, I talked about frame of reference, distance. The 3 things you need for a position. You should probably put that one down. 3 things for a position. Everybody remember what they are? Reference frame, direction, and distance from. Distance from the reference frame or the origin.
What were they?
Reference frame, distance from reference frame, and what was the last one? Direction. Okay. And I reviewed with you position time graphs, some basic grade 10 position time graphs, like positive motion is to the right, negative is to the left. Do you really have to study that? If you don't know that positive is to the right, you've got bigger problems. Okay. There was another booklet that was entitled Straight Line Kinematics. We did a whole bunch of calculations in there. We calculated displacement. You could write down calculate displacement. It really wasn't that challenging. And then we did a very little bit on position time graphs. We drew a position time graph from a story, much like you did on this assignment. This assignment here, the sideways one that some people are still working on, is pretty much a review of the test, which is why I wanted you to have it done prior to today. Okay, so you need to be able to draw a position time graph from a story, from a word, from a sentence. Something like the ball is thrown up in the air, it lands on the ground at 10 feet, or at your feet 10 seconds later, and so on. Yeah. Perfect. I introduced you to the motion detector. We played with the cart, right? You got a better handle on that. We did some more notes on linear kinematics. Talked more about slope. The bigger the slope, the faster the speed or velocity. You should know the difference between constant motion and variable motion. Constant motion, the position time graph is what? Linear or straight, right? Do you guys know the difference between straight and flat?
Yeah.
Okay. What would variable motion look like? It'd be curved. We talked very briefly, ironically enough, or apropos enough, I guess. We talked about the difference between an instant of time and an interval of time. I do remember speaking to you very briefly about that. An interval of time is, right, 2 time points. The difference between an instant is simply 1 reading. There was a hand-in assignment, Jordan, that said hand in at the top. with a ladybug. I know you handed it in. Okay? That many of you did. And I got it back to many of you. You should have a look at that and see if there's any problems that you have. If you don't understand the mistakes you make, you should come see me. Is anybody going to get too worried about the velocity crossword? Do you need to be able to solve little equations like this? I would pretty much expect to be able to do that coming in the door on September 1st. So, really, you shouldn't be studying that. But if you don't know how to do it, you better learn real quick. Okay, then we got into a big booklet on types of velocities. And I think Anne's has already got them up there, right? Well, sort of, right? Types of velocities: constant velocity, average velocity, instantaneous velocity. There was a whole booklet on that. We did word problems. We did slope problems, where you're taking the slope of a position time graph. We learned about taking the slope of a tangent. I see on these, some of you haven't learned how to do that yet. So that's why I need to get those back to people today. Okay? There was another, this was Johnny Physics, which I haven't got from some of you. I would love to give it back to people, but I can't because some people have not handed it in. Some people have not completed the position time graph quiz on Schoology. There's about 5 or 6 of you that haven't done that. Some of you did it yesterday, I saw. If you haven't checked your mark yesterday, you need to do that. You need to figure out what you need to get in. The rolling ball lab, I won't ask you anything about that on the test, but you should have it done. Right? Some of you have got, I need to do some more marking on that. We got into acceleration. Okay? Do you need to know what acceleration is? Absolutely. There's probably still some people that don't have a really, really good grasp of what acceleration is. You've got about a 24-hour period to figure that out. Okay, so please ask it. We did a whole bunch of notes on acceleration. Should you know the formula for acceleration? A equals v over t. Which v is it? Anderson might have a tough time putting the delta there. Average. Change, right? You should probably be able to know answers to like similar to another, right? Remember what acceleration is? Delta v over delta t. Can you just type delta? You could. You also need this. This you must know. V bar is not equal to delta v. And I'm not going to say give it to you in a true and false question or anything like that. It's going to be embedded in a question. But there will be people tomorrow that will use a value for V bar in place for delta V. And then I will write this on their test. Okay? I see it year and year and year over and over and over. So, watch out for that. I shouldn't say we talked about Galileo's experiment, right? You should be somewhat familiar with it. Somewhat familiar with Galileo's experiment. I said that on the test there would be this chart. It's not on tomorrow's test. You will do that on Monday.
Oh.
Woo, hi, hello. You will do that part on Monday. That will be a group thing. Okay? I would expect you to be able to handle something like this acceleration worksheet. It's kind of hard for me to do all this because I keep sort of just really doing what? Repeating, talking about the same things over and over. Okay? So, if your plan all along was to just study the night before, that's a poor plan. You should have been paying attention all along. Because I keep repeating myself. Okay. Then we get into velocity time graphs. Now here's where things get a little more challenging, right? Velocity time graphs. Remember velocity time graphs, you can find the displacement by finding the area. Make sure you know how to do that. Okay? Remember there was 2 sheets in there that were very, very crucial. I highly recommend you have some form of that on your cheat sheet for tomorrow. Okay? Some form of this on your cheat sheet. Yes. Below the graph. If the graph is below 0, the displacement is? Negative, and you actually go not below the graph, but actually go above. Okay, and then after that, it was just word problems. You can just, I guess I should also say the ticker tape stuff, right? Yeah, put the ticker tape stuff in there. And word problems. There will be several word problems.
Acceleration word problems?
Oh, yes.
Oh, good.
Okay? I'm sure you'll all do just fine. You will know if you don't. I mean, will you be a chance for a redo? Yeah, because you know what, the next unit is really built on this one. So if you don't do well here, well, you're going to have to learn it for the next unit because it just keeps building. That's the nice thing about physics. It just keeps on building. Okay? I'm going to give the late people, I'm going to give them until 1:55 to hand it in. After that, they will go to the back room and we will go through this with everyone. Okay? You have until 1:55. I highly recommend the rest of you start working on a cheat sheet. And I would work with a partner if I was you. Good stuff.